Hi and welcome to this third video lecture. So this will be about uniform motion. So as we are equipped with some of the quantities that are there in motion, now we can deal with motion head on. So what is uniform motion? Uniform motion simply means that a particular body is going with a constant speed. That is, it's doing a constant amount of distance in a particular interval of time. So if you take any amount of time, let's say 2 minutes, then it's doing something like 500 meters in every that amount of time. Alright, so before we go and deal with uniform motion mathematically and graphically, let's deal with what all types of motion we'll be studying. You can define types of motion based on various categories, like this whole chapter is about motion in 1D, right? So, on the basis of how many dimensions or how many degrees of freedom a body has, you can define it to be a motion of 1 dimension or motion of 2 dimension or a 3D. So if you're moving along a line, it's a motion in 1D. If you're moving in a plane, then it's motion in 2D. And let's say there's a box and inside it gas molecules are there. So motion of these particles will be motion in 3D. You could also define types of motion on the basis of the curvature of the path that takes. So if it's moving along a line, it can be called as rectilinear motion. If it's moving in a circle, it will be a circular motion. If the body is rotating about any point, then it's called rotational motion. And if it's doing to and fro motion in this way and this way, then again this way, then it's called periodic motion. But for the purpose of this video lecture, we'll not divide motion into any of these categories. We'll define it altogether differently on the basis of state of motion, that what exactly the body is doing in terms of its velocity or speed also you can say. So first thing you can say is uniform motion. Second one will be uniformly accelerated motion, and third will be non-uniformly accelerated motion. So what's happening in each of the cases? In uniform motion, a particle which is moving with a speed v is continuously moving with the same speed v. In uniformly accelerated motion, a body starts with some v but changes its velocity. Let's say v plus x after some time, then it will be v plus 2x after some time, right? So this is uniformly accelerated motion. Its speed is increasing by x after each interval of time. The third part of motion is non-uniformly accelerated motion. That is something like, let's say speed initial is v, now after some time it's v plus x, then after some time it's v plus 5x. So this is non-uniform increase. In first interval it increased by x, in second interval it increased by 5x. So we'll deal with motion in this regard. Alright, so let's deal with uniform motion. So how did we define uniform motion? Uniform motion was the motion in which speed remains constant. As simple as that, right? Speed is defined as distance over time, and in this case this thing is constant, it's not changing. So if this is not changing, it's a number, let's say 10 meter per second, then it means that if you take time equals 1 second, then it's traveling 10 meter regardless of which part of motion you're looking. So you can see this car is not moving at all. Its speed is 0 meter per second. Now it starts moving with, let's say, some uniform speed of, let's say, 10 meter per second. Once we say that, we can say that it's moving 10 meter every second. Here also, next also, right? So typically we'll deal with 5 major quantities. First quantity you can say is displacement. Second quantity will be v naught, that is speed at time equals to 0. We'll also represent this thing by u, that is initial velocity. Third quantity we'll be dealing with is velocity after some time t. We can also say this thing to be simply v, or final velocity. The fourth thing will be acceleration, that is we have already defined rate of change of velocity. And the fifth thing is obviously time, right? So in motion we'll be dealing with mostly these 5 quantities. Other quantities can also come depending on what kind of motion it is. Like here we have only defined one acceleration, but what if it's motion in non-uniform acceleration? Then you'll have a naught, that is acceleration at initial time, and at, acceleration at final time also. But normally we'll deal with only these 5 quantities. Okay, so let's discuss what all these quantities are in uniform motion. So uniform motion, let's take an example. Let's say a body started with some velocity v and it covered a distance s. So you can say s equals v into t, right? That's my displacement. What is my initial velocity? It's v. What is my final velocity? It's v. What is acceleration? It's 0, because velocity or speed hasn't changed. If it's a uniform motion in one dimension, then we can say that speed and velocity are the same thing, right? So speed or velocity hasn't changed, acceleration must be 0, and time taken was simply t. Okay, so let's try to plot a graph of this motion. So let's take any example. Let's say this is Iqbal, and this Iqbal is running with some constant speed of 5 meters per second and started from point A. It reached the point B. Let's say the distance between them was 100 meters. So let's try to plot this graph. Now, if you remember, velocity or speed, let's talk in terms of velocity, is equals to displacement over time, right? That's why we get its unit as meter per second. So it's 5 meter every second. We'll deal more with the graph when we'll go into motion with uniform acceleration. For right now, we'll not deal with slope and areas under the curve, but we'll just simply see how to plot a graph, and that's it. So let's draw two axes like this. This y-axis will be my distance or displacement, and this x-axis I'll represent time. Alright, so it starts from displacement 0. It has 0 displacement at 0 time. Then after 1 second, you'll see that it has moved 5 meters. So this is the point which I am looking for. Then after 2 seconds, you'll see it has reached a distance of 10 meters. Then 3 seconds, it will be 15, and so on. So you'll get some points like these, right? And as you can see, all of these points will lie along a straight line. So this is how your displacement or distance time graph will look like. This straight line curve simply says that y-axis is changing uniformly with x-axis. That is, displacement is happening at the same rate. If you take any interval of time, let's say I take 2 seconds of interval, then in that 2 seconds, this is my displacement. Let's take another 2 seconds, that is from 2 to 4. So in this 2 to 4, you'll see that my displacement is still the same, which will be 10 meters here and 10 meters here. Now what about other types of graph like velocity time graph and acceleration time graph? So those graphs will be quite simple in this particular case. If I make velocity time graph, let's say this is v and this is time, and let's also make acceleration time graph like this. Now velocity as it is constant, or you can say speed as it is constant, so velocity time graph will look like this, a straight line and a horizontal line, as velocity is not changing with time. And as velocity is not changing with time, you can say acceleration time graph will look like this. So acceleration is 0 at each and every time. Alright, now let's see how to deal with uniform motion in one dimension. So as this motion is in one dimension, you can always take the motion to be on a number line. So this is 0, this is 1, this is 2, this is 3, and on the left hand side we'll have negative numbers like -1, -2 and -3, like this. So this is just a convention that we take right to be positive and left to be negative, right? Same is the case with y-axis. So if one dimensional motion is happening along y-axis, then you know that top will be positive and bottom will be obviously negative, right? Okay, so now how to deal with it? First of all, let's take an example. So let's say an object started from point 2 and it moved along this line and it reached point 3. So we have already defined two things for it, xi and xf, that is initial position and final position. Now let's deal with all of those quantities. So first thing, let's say the time taken is equals to t. Next, what is the displacement? So displacement, we can say, is equals to xf minus xi, which is also called as delta of x. This delta means change in. Third thing will be its velocity. So velocity is delta x over t. Finally, how about its acceleration? So acceleration as it is defined as delta v by t, and as we know that delta v is equals to 0, so acceleration comes out to be 0. So all of the uniform motion, there's only one formula, or it's not even a formula, it's the definition of velocity or definition of speed. So you have only one formula, which is displacement equals to velocity into time, or in case of speed, distance will be equal to speed into time taken. Alright, so let's check our understanding with some problems. So this problem says a train leaves station A and is traveling at a constant speed of 25 meters per second. So let's say we have two trains over here. So this is the first train, this is the second train. What are they doing? They are moving from some station A. What is the movement speed of train? First, 25 meters per second towards station B. So somewhere over here is station number B. Now, another train starts moving at a constant speed of 30 meters per second. So this is train number 2. He's traveling with 30 meters per second. But he started off 30 minutes later. Find the time after which first train will catch up to the second train. Now that we have clear understanding of the problem, let's start. So let's assume that this is the position, some position C, where both of them meet. And let's say it took the first train time t to reach there. So let's write the equation for the first train. For the first train, we can simply say that distance traveled x is equals to speed, which is 25, into time t, where t will be in seconds. We have another equation as well for train number 2. Now train number 2 is also traveling the same distance because they are starting from the same point and they are meeting at point C. So it's also traveling a distance x, but it's traveling that with some higher speed, 30. And obviously it will take him a smaller amount of time. How much? That will be t minus 30. But 30 is in minutes, right? So we have to convert it into seconds. Now, as we can see, we have two equations, 1 and 2, and two variables, x and t. Let's solve for them. So what do we need to find? We need to find the time. So let's equate equation number 1 and equation number 2. So if we equate it, you'll get 25t equals to 30 into t minus 6 into 3, 18, 2 zeros. So this makes 25t equals 30t minus 30 into 1800. This goes here as 5t equals 30 into 1800. T equals 6 into 1800, which is basically 6 into 30 minutes, which is also equal to 3 hours. So what's the final answer? After 3 hours, they'll meet each other. This problem says, by walking 3/4 of my usual speed, I reach my office 20 minutes late. What is my usual time of commute? Okay, so this is like one of those cheeky problems which like get over very fast without giving you much information, right? So how to deal with this? So whenever you think, and I've said this earlier also, whenever you think something should be given in the question, just assume it. Let's assume the distance between them is d. Let's say it travels with its usual speed v and it takes usual time t to reach there. So this is what we need to find. Now this is a new day. In this new day, I'm traveling the same distance d, but I'm not traveling this distance with the same speed. I'm traveling with 3/4 of my velocity, okay? And as I'm traveling slower, obviously I'll take a longer amount of time. So I'll take t plus 20. If you keep here time in minutes, you'll get answer in minutes. Okay. Again, we have two situations. Let's write the only equation which I have, that is distance equals speed into time, or displacement is velocity into time. So you can say d is equals to v into t from first part. From this part, you can say d is also equal to 3/4 of v into t plus 20, right? And I don't need to say what to do next, right? Equate both of them. If you equate both of them, you'll get v into t equals 3/4 of v into t plus 20. V gets cancelled. See? You don't need v, you don't need d. Everything is in t, and that is what is asked. So 4t equals 3t plus 60. So t equals 60. We took everything in minutes, so answer will be 60 minutes. So it usually takes me 60 minutes to reach, but as I'm traveling with lesser 1/4 of speed, then I'll take 80 minutes now. Okay, so this final problem is kind of a puzzle. It says, if I run the first lap of a track with an average speed of v meter per second, how fast should I run the second such that the net average speed of total motion becomes twice of the first lap, that is 2v meters per second. Alright, so let's say the length of this track, the distance of this track is d. So S is basically d. Distance will be d. My average speed for the first loop is v. So let's say the time taken was t. So I can say v is nothing but d over t. Let's take it as t1 because we have 2 laps. So t1 will represent time taken in first lap and t2 will represent time taken in the second lap. So this will be my second lap. Now let's say I'm doing this with some velocity v2, right? And this is what I need to find. How fast should I do the second lap? Okay, now let's consider the whole scenario. So if I consider the whole scenario, the distance traveled was 2d. The average speed by which it travels that distance is 2v, and time taken will be t1 plus t2. So let's write the equation for this guy also. So I can say 2v equals 2d over t1 plus t2. But I also know v is also something else. So I can write this as 2d over t1. Okay, so we got something like this. What is this? 2d equals 2d, t1 plus t2 equals t1. How can be that t1 plus t2 equals t1? That means t2 is equals to 0. And that means v2, which is basically distance traveled by t2, is tending towards infinity. What? There must be something wrong, right? As it turns out, there is nothing wrong. It's a tricky problem to let you think that you have done things in a wrong fashion or you did some mistake mathematically, but you didn't. Let's understand what is asking. So he's asking, let's say I'm traveling a track. The first track I traveled with 2 meters per second. And let's say the length of this track, the length is 4 meters. Let's assume. So how much time will I take to cover this? Obviously 2 seconds. Now what do I want is my average velocity to be 4 meter per second. So if my average velocity is 4 meter per second and I have to travel a distance of how much now? Twice the distance, so 8 meters. So how much time will I take? I'll take 2 seconds. So if I want to double my average speed by just increasing the speed, it cannot be done because we have already wasted our 2 seconds in the first lap. I cannot do it the second lap in 0 amount of time. So the answer to this problem is simply that it's not possible. There's no amount of speed which it can travel with so that his average speed will become twice the initial average speed. Alrighty then, so we have reached to the end of this video. So what are takeaways of this video? So the first takeaway of this video is this thing is pretty simple. This is 9th class stuff, right? If not even 9th class, you did all of this problem in 7th class, that this train is moving with 60 km per hour, how much distance it will travel in 2 hours, or train A is moving from station A, train B is moving from station B, this is moving with this speed, this is moving with this speed, at what point they'll meet. So all of these questions are pretty simple because there's just one thing or one relation that relates all the quantities, or all the other things are equal to 0. So what is the only thing? The only thing is distance equals speed into time, and displacement will be velocity into time.